Welcome to another video. This one, I'm going to start solving this 1993 AP Calc BC multiple choice part of the exam, okay? So let's get started right away. We have the first one, area of the region enclosed by the graphs, y is x squared and y is x is equal to what? So these are easy to visualize, so I can even sketch it here right now. X squared is always positive, so it looks something like this, parabola. Y equals x is just a straight line. It looks something like this, okay? We can confirm that the upper curve is the linear one, okay? And the lower curve is the parabola. We know that if we plug in like x is 0, both are 0, so we know that this is not sketched well, but we know that there's a point of intersection x is 0, it's 0, 0, and there's another point of intersection here. Where is that? At x is equal to 1. Okay, if you couldn't visualize that, you could even just set these two equal to each other. X squared is equal to x, so you solve for x. X squared minus x is 0, you factor out x. X times x minus 1 is equal to 0, so x is 0 and 1, which is what I just said. Okay, if you can easily visualize it too from here, and you could easily plug in some numbers too if you are able to do it in your head. Okay, so let me mark it in this sketch, okay? So that's this point here, and that's this point here, okay? So we can even plug in a number in between, like half. So for the linear line, y would be equal to half. The parabola, it'll be y is a fourth. So we know that the linear line is the upper curve, and the parabola is the lower curve, okay? So area is upper curve minus lower curve, and our limits of integration are from 0 to 1, which is the points of intersection we found. That's the limits of x where our region is in. Okay, this is just parallel, x squared over 2 minus x cubed over 3. Evaluate from 0 to 1. This is just half minus a third. You simplify, you get a sixth. If f of x is x squared plus 2x squared plus 1, then limit as x goes to 0, f of x minus f of 0 over x squared is, okay, so this is not the definition of the derivative, so don't get confused. So let's just plug in when x is 0. F of 0 is 1, or it would just be f of 0 minus f of 0, that's 0. And then the bottom would be 0. That means we have an indeterminate form. We can use L'Hopital's rule. Okay, so we take the derivative of the top. What would that be? That is just, so let me just continue from here. It'll be f prime of x minus derivative of a constant. F of 0 is just a constant. We found that to be 1 even. Derivative of 1 is 0. Okay, so we just left with f prime of x on top. The bottom we have derivative of x squared is 2x. Okay, so what is f prime? Let's do it over here. F prime is, that's just 4x. Okay, so let's plug this in as f prime of x. So we would get limit x goes to 0, 4x over 2x. So this becomes limit x approaches 0. This simplifies to a simple 2. Okay, so our answer is C. P is a polynomial of degree n greater than 0. What is the degree of the polynomial q, integral from 0 to x, p of t dt, okay? So we know that we know that q prime, by the fundamental theorem of calculus, is just p of x, okay? So if p is a degree of n, we can integrate both sides, right? Then q would be, we use the parallel, it would be n plus 1 degrees, so it will be e. Okay? Particle moves along the curve, xy is equal to 10. If x is 2, dy dt is 3, what is the value of dx dt, okay? So this, since dy dt, since the derivative of y is with respect to t and derivative of x is with respect to t, this is the same thing as x of t times y of t is equal to 10. So if we want to differentiate this, we need the product rule, okay? So it would be, so first d second plus second d first. So first, so I'll just write it as x. Derivative of second would be dy dt, okay? Plus second, d first derivative of x is dx dt, okay? Derivative of 10 is just 0, so that's easy, okay? So now we plug in. X is 2. Dy dt is 3. Okay? We could find y, actually, because when x is 2, we plug into here. 2y is equal to 10, or y is equal to 5. So y, 5 times dx dt is equal to 0. Okay? So we solve for dx dt. So dx dt is minus 6 over 5. That is B. Let's move on. Which of the following represents the graph of the polar curve? R is 2 secant theta. Okay, so there's multiple ways to do this. If you just want to start plugging in values of theta, that's fine. When theta is 0, R is 2. Okay, so we can already eliminate this guy because when theta is 0, R should be pointing in this way. This guy should be 0 over here. It should be R is 2, so it should be somewhere over here, but it's up there right now. So we can eliminate that. Okay, we can also eliminate this. We can also eliminate this. So we are left with these two left. Okay, we know that secant theta is undefined when theta is what? That's pi over 2. So it would be infinite. So it would be this guy. Okay. Another way to do it is, well, I know that we know the definition of R and X, or X is R cosine theta. Okay. That's just a definition. That's how we do, get polar coordinates, right? X is R cosine theta, Y is R sine theta. Okay, so we can do R over secant theta is equal to 2. 1 over secant, that's the same thing as R cosine theta is 2. R cosine theta, we just said is X. X is equal to 2. Okay, and that's this vertical line here. So we get the same answer. If x is t squared plus 1, y is t cubed, the second derivative is, okay, so the first derivative is easy. dy dx is dy dt over dx dt. That's easy. dy dt, that's just 3t squared. dx dt, that's just 2t. Okay, so then we simplify. We get 3 over 2 times t. Okay. Let me, what did I pre-do it? Oh, okay, over here. I'm just checking my previous work in line with it right now. Okay, 3 over 2 times t. So the second derivative, if you don't remember it, let's take d like this, okay? It is, we differentiate with respect to t, dy dx, and then we have a dx dt on the bottom still. Okay, so if we differentiate dy dx with respect to t, that's just 3 over 2. The bottom, we get what? We get 2t again. So this becomes 3 over 4t. So 6 is A. Okay. Integral from 0 to 1, x cubed e to the x to the 4th power dx. I don't think I did this beforehand, so I will do it now. We let u be x to the 4th, du 4x cubed dx. Okay, so our integral becomes, let's change the limits after. It would be du over 4, so a 4th du, and e to the x to the 4th is just e to the u. We have to change our limits of integration. When x is 0, u is 0. When x is 1, u is also 1. So we get the same limits coincidentally. Okay? This guy is just 1/4 e to the u, evaluate from 0 to 1, which is just 1/4 times e minus 1. 7 is A. If f of x, I believe I did this in the AB exam. This one's very easy. If f of x is ln of e to 2x, f prime is what? Well, we can rewrite f as 2x. The ln and the e are inverses, so we get 2x. So f prime is just 2. Okay? If you didn't see that, you can just differentiate this with the chain rule. You'll get the same thing. Okay? But clearly this is the faster way. F is 1 plus x to 2/3, which of the following is not true. Okay? It talks about, is it continuous? Well, we know that this is continuous for all real numbers, x to 2/3. It's the domain is negative infinity to infinity. Okay, so it's continuous. So we can eliminate that already. Now let's talk about minimum, increasing, and f prime, and even f double prime. So let's differentiate f. So f prime would be 2/3 x to the negative 1/3 power. Or we can write this as 2 over 3 times the cube root of x. Okay? So we know that f prime does not exist when x is equal to 0, because it will be divided by 0. So we can already choose that D is false. Okay? Which of the following functions are continuous at x is equal to 1? Okay. ln of 1, is it continuous there? It is. ln of 1 is just 0. So let's write that. E to the first power, that's a valid value. That's just e. So it's continuous there. How about limit? Okay, well, let's plug in first. ln of e minus 1, okay? That is also existent. So all three should be continuous, and their limits are these values. Okay? So it's continuous. All three are continuous. We have this improper integral from 4 to infinity, negative 2x over cube root of 9 minus x squared. So I see that we could do a substitution. U is the 9 minus x squared. Then du is minus 2x dx, okay? So that's what I did over here. So we rewrite our integral as minus 2x dx is du. And bottom we still have cube root of u, okay? We have to change the limits of integration though. When x is 4, u is negative 7. 9 minus 16, that's negative 7. When x is infinite, we actually get negative infinity, because 9 minus infinity squared, okay? This is not the proper notation, but it's still doable. This is multiple choice, so you can write it like this, okay? You don't, since you're not showing your work. Or they don't check your work. Okay, so we integrate this, that's just parallel, minus 3 over 2, u to 2/3. Evaluate from, so I flipped the limits and added a negative sign, okay? So negative infinity to negative 7, okay? We know this is divergent because when we plug in the lower limit, it is infinite, okay? So we know that this is non-existent. Position of a particle moving along the x-axis is, x of t is sine 2t minus cosine 3t for time t is greater than or equal to 0. When t is pi, acceleration of the particle is, so we want to get acceleration, which is the second derivative of x, okay? So we want x double prime. If this is x, velocity is x prime, so we differentiate this. That's 2 cosine 2t. Derivative of cosine is negative sign, so it becomes plus 3 sine 3t. This 3 and 2 came from the chain rule. We differentiate v to get acceleration, so this will be the second derivative of x. That's what? Cosine, derivative of cosine is minus sine, so minus 4 sine 2t. Derivative of sine is cosine, so 9 cosine 3t. We evaluate that t is equal to pi. Sine of 2 pi, that's 0, so that goes away. Sine of 3 pi, that's negative 1, so negative 1 times 9, that's negative 9, okay? You again. dy dx is x squared times y. then y could be, well, we just do separation of variables here to solve this differential equation. Move all the terms with y on one side, move all the terms with x on the other. So we divide by y on both sides and multiply this dx on both sides. So it becomes dy over y equals x squared dx. We integrate both sides. This side is just log of y. This side is just parallel, x cubed over 3 plus c. We want y to be exponentiate. So y is c e to the x cubed over 3. Okay? Remember, if we exponentiate, it's e to the x cubed over 3 plus c, which we can rewrite as e to the x cubed over 3 times e to the c. E to the c is just some constant c, so I moved that to there. Okay? So which one is that? E to the x cubed over 3 is what we want, which is this one, some c, like 2. 13 is c. Okay. The derivative of f is this guy, so let's mark that as f prime. Okay, did I do this beforehand? I should have. Let me find where my paper... Oh, okay, I flipped the two problems. Okay, so derivative of f is this guy, so that's f prime. Okay, so I marked that right away. At how many points will the graph of f have a relative max? So we want to do the first derivative test. Okay, this is the first derivative. That's what it told us. So our critical points are x is 0, 2, and negative 3. Okay, so 0, 2, negative 3. We do the first derivative test. We plug in some huge negative number. So that's somewhere in this interval. This x to the fourth is always positive, so we don't have to worry about that. Huge negative minus 2, that's negative. Huge negative plus 3, that will still be negative. 2 negatives make a positive. Plug in some number between negative 3 and 0, like negative 1. Remember, this is always positive. Negative 1 minus 2, that's negative. Negative 1 plus 3, that's positive. Negative times positive, negative. Plug in a number between 0 and 2, like 1. This would be negative, this would be positive, so the sign is negative. Plug in a huge positive number. Positive, positive, positive. Okay? So what does the question ask? Where the relative max is. How many of them are there? There's only one, because the derivative changed from positive to negative only at this point. F of x is e to tangent squared x. F prime is, okay, so this is just chain rule. Derivative of e is e. Okay? Derivative of tangent squared, this is chain rule because we have to outside in. Derivative of tangent squared is just 2 times tangent x to the first power. Okay? And then times derivative of tangent is secant squared. Okay? So that's your answer. It should be, looks like D. And that's correct. Okay? If you want to rewrite f as, if this helps you out, the exponential of tangent x squared, so you can go outside in. We first differentiate the e, which is what we did there, times derivative of tangent squared. We need the power of 2 tangent to the first power, that's here, times derivative of tangent, that's secant. Okay, so sometimes writing like this might help you, especially if it gets more complicated. Okay, which of the following series diverge? Okay, this first one, we can compare it with 2 over k squared, okay? Because k squared plus 1, this guy would be smaller than this guy, okay? The numerator is bigger, so each term is going to be smaller, okay? We know this is convergent because it's a p series with p is equal to 2. So it's convergent, okay? So since this converges and this is even smaller, this has to also converge. Okay? This guy is a geometric series. And 6 over 7 is less than 1. So absolute value even is less than 1. So it's convergent. Okay? Remember, for a geometric series, the common ratio, the absolute value of the common ratio has to be less than 1 for it to converge. Okay, this is just the alternating harmonic series. And we know this converges. Okay, so none of them diverge. Slope of the line tangent to the graph of ln of xy is equal to x at the point where x is 1 is, okay, so we just implicitly differentiate because slope of the tangent line, that's just signal. Let's find the derivative. Okay, we have ln of xy is equal to x. We implicitly differentiate, so 1 over xy, that's derivative of the log, times derivative of xy, we need the product rule. So it'll be first d second plus second d first. So first d second, that's whatever second actually. Over here, so x dy dx, plus second, d first derivative of x is just 1. Derivative of x on this side is just 1. Okay, so we solve for dy dx, and multiply both sides by xy, that's what I did here. And then I subtract y on both sides, and then I divide by x. Okay, so that's dy dx. Evaluate at 1 comma e. How did I get that? Well, we want when x is equal to 1. What's the y coordinate? So we just plug in 1 as x over here. So ln of 1 times y, or ln y, is equal to 1. Y is equal to e. So our point is 1 comma e. We plug it into here. We get e minus e over 1, which is just 0. Slope of the tangent line at that point is 0. E to the f of x is 1 plus x squared. Then f prime is equal to what? Okay, so I just wrote this as, instead of f of x, it's y, and we're interested in what y prime is. Okay, so notation-wise, I just cleaned it up a little bit, or simplified it in my opinion. E to the y is 1 plus x squared. We can log both sides, so y is equal to log of 1 plus x squared. And we just find what y prime is. Y prime is, we need chain rule, 1 over 1 plus x squared times 2x. Okay, so that is B. Okay, we are 22 minutes in. Let me see what the next problem is, or the next set of problems is. Okay, let me maybe finish up to number 20 and then I'll call it apart. Shaded region R in the figure above is rotated about the y-axis to form a solid whose volume is 10 cubic units of the following, which best approximates x. Okay, so we want to use the shell method here, because if we use the disk washer method, it'll be much more complicated. Okay, so to use the shell method, well, first of all, we're rotating about the y-axis, so here, we need to draw a representative r and a representative h, lowercase r, lowercase h, okay? So if this is a representative h, hopefully you can see that on camera, then this is the representative lowercase r, okay? And we know by the shell method, its volume is 2 pi integral r h dx, okay? So our limits of integration are from 0 to k, in terms of x, the x limits. What's r? For any representative h, our r is just x. Okay? What is h? That's just the function. That's kx minus x squared dx. Okay? So we just solved this. So let me now shift to this page where I did it. So this line is this line over here. I just set up the integral, okay? This integral is equal to 10 because that's what the problem tells us. Okay, and then we just start solving for k. So I first distribute this x to both terms, so kx squared minus x cubed. All right, and then here we can just do the power rule. Kx cubed over 3 minus a fourth x to the fourth, evaluate from 0 to k. So we plug in x equals to k and x equals to 0. So you got to be careful with their variables, okay? So when x is equal to k, we get k to the fourth over 3 minus a fourth k to the fourth, that's here. When we plug in 0 as x, those both will go away. Okay, so this is how I got to this line. Now we start simplifying. I divide both sides by 2 pi. So that's what we have left over here. Then I multiplied actually by 12 on both sides to get rid of the fractions over here. So 12 times 10, that's just 120. 120 divided by 2 pi is 4k to the fourth minus 3k to the fourth, which is equal to k. Okay, I just reduced these two terms to k to the fourth. Now we just plug this into the calculator. K is 2.09. That's this one. Okay, so shell method was the way to solve this one. All right, last one for this part. Particle moves along the x-axis so that at any time t greater than or equals 0, the acceleration of the particle is a of t is e to the negative 2t. If at t is 0, the velocity of the particle is 5 over 2, and its position is 17 over 4, then its position at any time t greater than 0 is, this is just a simple antiderivative problem, okay? So we are given the acceleration and initial conditions of velocity and position, so we can easily find the position, okay? So let's find the velocity first. Velocity is just the integral of acceleration, or the antiderivative. So let's integrate this guy. That would be minus half e to the minus 2t plus c. You can even double check if you differentiate. Minus 2 times minus a half would be positive 1 times e to the negative 2t, which is what we have there, okay? Initial condition, v of 0 is what? They give us 5 over 2, which is equal to, we plug into here, minus half times 1 plus c. E to the 0 is just 1, right? So c is equal to 5 over 2 plus 1 over 2, so 6 over 2, which is 3. So our v of t is minus half e to minus 2t plus 3. Okay, so now we integrate velocity to get position. X of t would be plus 1/4 e to the minus 2t plus 3t plus c. Okay, now we have the initial condition. Position is 17 over 4 when t is 0. So x sub 0 is 17 over 4, which is equal to 1/4 times 1 plus 3 times 0 plus c. So c would be 17 over 4 minus 1 over 4, which is 16 over 4, which is equal to 4. So therefore, we plug in c, this c over here, that's 1/4 e to the minus 2t plus 3t plus 4. That looks like e. Is that correct? Yes. Okay, this one will take longer, so I'm going to stop the video here. Okay, so please like this video if you found it helpful, and please subscribe to also get notified for the next